Hello again, Internet. Welcome back to our second Lunch and Learn. Again, our guest is Avdi Grimm, and without further ado, I give you him.
Well, hello again, and so Tuesday I was working with Ro and Micah, right? Got it right. And we were working on extracting out a library which was wrapping Neo4j. And so that kind of gave me the idea that maybe we could talk a little bit about some practices for building libraries, particularly building libraries for extraction into gems, and some guidelines. And I'll talk about some guidelines that I've come up with over the years, and you guys can tell me some of the guidelines that you use. So I thought I'd cover basically four areas: the distribution of the library, the sort of the packaging of the distribution, the coding style that you use, API design, and then take a separate look at the error API design. So distribution. Number one, I think it's usually best to try to limit the dependencies that a gem has on other gems, and particularly other gems which may modify the global environment. So active support is awesome. It makes a lot of things easier, but it also modifies a lot of built-ins, and that depending on where your library is being used, that may limit somebody's ability to use your library because it may actually conflict with something that they've done in a project that doesn't use active support. So as tempting as it can be, try to keep things as much as possible to the Ruby built-ins. And if you have dependencies, try to make it on things that don't modify Ruby. Semantic versioning is a wonderful thing. Is everybody here familiar with semantic versioning? So you've got your major number, your minor number, and your patch number. Patch versions are strictly for fixing defects. They shouldn't add functionality. Minor versions are for adding functionality, but they should never break anything that already works or change anything that already works. And then you use your major numbers for backwards incompatible changes. And when you do this, you make the tiddlywaka in gem files a lot more useful because they can pin to a major version and rely on the fact that you won't break anything when you introduce a minor version, because your minor version is only going to add functionality. It's not going to change something that already works. This isn't a big problem, but don't name your library after a pattern. That's just confusing, because then somebody's you're going to be talking about active record, and it'll be confusing whether you're talking about the pattern or the library, or you have a situation like Data Mapper, which is a wonderful library, but it doesn't actually fully implement the Data Mapper pattern. So you're talking about Data Mapper, but it isn't actually a Data Mapper, and yeah, just don't do that. All right, so let's talk about how we write the code in a library, some guidelines for that. First and foremost, don't monkey patch, especially don't monkey patch anything you don't own. And if you do own it, then you're not going to be monkey patching it. Especially not Ruby core stuff, but even I've run into a lot of issues with libraries that would patch something on another library, and then that would conflict with something in somebody's code base. Where they had patched the same library or something like that. So unless the purpose of the library is to monkey patch, if it's like active support where you're adding a bunch of stuff and you're explicitly documenting what you're adding to the core, just try to avoid that. It avoids so much pain. Let's stop naming classes base. It doesn't tell you anything. And it usually indicates that there's a concept that hasn't been sufficiently teased out, or identified, and it makes grepping through the code base a pain because you find all kinds of things that are named the same way. If there's a concept, try to identify it, and give it a name. Like, you know, maybe active record base could have been called active record record or active record model. There are, you know, I mean, if you're actually dealing with something called bass, like, you know, baseball or bass jumping or, you know, Swedish 90s pop group Ace of Base, then, you know, go for it. But otherwise, let's get away from classes named bass. Okay, so this is always fun. You've got a library that has some API methods that can be called with a block. So client code is going to call it with a block, and then there's going to be more client code inside the block. And you know that there are some errors here, some internal errors that you want to catch and handle. So you rescue generic runtime error. And what happens is when your client code says with sandwich do some other client code that might raise a runtime error, this silently eats that client runtime error, and that client probably really needed to see that exception. So try to be specific. Be very careful when you're handling exceptions in your library that may be raised from client code because of a yield or because of any kind of block handling. Try to be very specific about what you're rescuing and pass the rest on. Let's talk about API design, top level API of your library. We talked about this a little bit Tuesday. There's a sort of an idiom that's been emerging of this block style configuration. So you can see this in RSpec configuration. You can see this in a lot of Rails configuration and things that you find in Rails initializers. And I think it works really well when you have this like top level .configure, do, and then a config object. There are a few advantages to using that over like passing in a hash or requiring a configuration file or something along those lines. Number one, it's code as config, and code as config is just known for a long time that's one of the most flexible ways you can do your configuration. I mean, that's why Lisp is so great, because it's data and code at the same time. And so any kind of loops that somebody wants to do inside that configuration, they can do it. If they need to query something else inside that configuration, they can do it. One of the things that's less obvious about that is that it makes it the configuration very discoverable. So I don't know if you noticed, but back in this code, I actually, the last line there takes the waterfall height and multiplies it by 2. And you couldn't do that if you were just passing a hash of values in, because you would have no way of knowing what the default for that is. But here we can actually use the default value and then use that in setting a new value. And because each of these is a setter method, it gives you a place where you can come along later and, well, now or later, and add validations. So you can, if you want to be really nice to the client code and tell them when they've set a bad value immediately, you can add some validations in there very easily. Finally, you can if you code these right, you can make it so you can call them more than once. So like you can do things. RSpec configurations you can have as many of those configure blocks as you want, and so you'll see one initializer file which opens up an RSpec configuration and configures it for VCR. Another one that maybe opens up a RSpec configuration, configures it for Capybara or something like, Selenium, whatever, something like that. And it's nicely separated. They can all, open up configuration again and do their own configuration. It doesn't stomp on the other configurations. Here's something that I've been trying to do, which is to limit the requirements on client code that they know things about my class hierarchy and about my module hierarchy. So instead of having in my documentation saying, well, you're going to need to instantiate an SWS sandwich, I'll just say you just need to call sws.new sandwich, and that'll give you back what you need to get to the next step. And this has a lot of benefits. Number one, you've got this top-level API that kind of acts as a top-level reference, so they can see listed out the kind of top-level concepts that they should be interested in. A lot of times when you have them interacting directly with classes, you might have classes in there which are more sort of internal concerns, and then you also have classes in there which are the classes that the client code should be dealing with. And it's not always clear what they should be looking at, so they go to the RDoc page, and they've got this long list of top-level constants, and they're like, okay, which of these should I be interested in? Which of these should I click? What do I click through to see the documentation I need? This gives them a list. If you have these in your top-level public API in that module, this gives them a list of the things that they should actually be concerned with. And I think more importantly, it means that they're not going to be tied to the internal structure of your code. So they're not going to be. So you have a lot more leeway. If this is your API, you have a lot more leeway to move things around without doing a major version, because you're not breaking backwards compatibility. If you want to proliferate classes, like you realize that a concept is really better represented as a family of classes instead of a single class, you can do that, and you can have that top level new sandwich method return the right thing based on the arguments that it's given. It doesn't necessarily have to return a specific class. So this gives you a lot more decoupling in between the client code and your code. It gives you a lot more freedom to change things before you go to another major version. I like to treat the
I don't see an error.
Yeah, I was just introduced yesterday to this Tom Selleck waterfall sandwich phenomenon. I did not have time to find the perfect image for each slide, so I thought I figured that that would really, Selleck pretty much suits anything. It goes with anything. So you can figure out the mystical connection between each slide and the topic. I think it's pretty obvious once you think about it. I like to think about my error API as being just as important as the rest of the API that I'm documenting for my library. It is part of the interface, and it has a big impact on how people use your code. So one question that I come upon over and over again is, how do we structure the error classes for this library? And I've gone through a lot of iterations on that. And a lot of times you'll want to like look at maybe the structure of the library for that. Like if the library has 3 main modules, maybe you'll have a different error for each module, or maybe you'll have a different error for different layers of the library. But lately, what I've been doing is I've been trying to work backwards from how the errors will actually be used, and how code will differ based on the error. So I mean, the biggest reason, besides for having them carry different data, the biggest reason to even have different error classes at all, the biggest reason not to just raise runtime error everywhere, is because you want to be able to have separate rescue clauses for different types of exceptions, because you want to handle them differently. And typically, like, I think the 80% case is boils down to like 3 cases. The case where you say the client code did something wrong, or if this is user-facing, the user did something wrong, they need to do something to fix it. That's your form coming back saying these fields are invalid, you need to fix them. Then you have the logic error, which says we've detected that there's a defect in the code, somebody screwed up this library. There's nothing you can do about it except report it to to the person responsible. And finally, you have transient failures, which say there isn't anything wrong in the code and you didn't do anything wrong, but some service or some thing which this code depends on is, at least for the moment, unavailable. And probably the best thing you can do is wait, or maybe contact whoever's responsible for that service. And that's sort of, those are the 3 different error messages that I think we see most often. Those are the 3 different differences in how the exception is handled and presented. So I've started to structure my exception classes based on those differences. So you have your logic error, your client error, and your transient failure. Sometimes you run into an issue where client code might want to handle exceptions based on more than one facet of the exception. For instance, some client code might want to just log all HTTP errors triggered across the whole application, no matter where they're triggered. Another part of the application doesn't care about that, but it does care about handling ignoring errors from this particular library, and that can set up a conflict in how you structure your error hierarchy. But there's a way to get around that and kind of have your cake and eat it too, which is to use modules for tagging. So here I've got a module SWS error representing an error coming out of this application, and at the top level of the API, I rescue in this case HTTP errors, tag them with SWS error by extending them with the module, and then I re-raise. So raise, given nothing else, will re-raise the current exception. And now both of these pieces of example code are happy. One can switch on the fact that it's an HTTP error. The other can switch on the fact that it's an error from this specific library, and they're both happy. It can be nice for some types of library to avoid raising exceptions entirely. So this is an example that I stole from the Typhoeus README. And Typhoeus makes a point of never raising exceptions. It's sort of the polar opposite of NetHTTP, which can raise at least 3 unrelated types of exception. And just when you think you've handled all possible exceptions that can come out of NetHTTP, it throws another one at you. Typhoeus never raises, but what it does do is it gives you a response object which can tell you exactly whether it was a success, whether something went wrong, and it gives you the opportunity to go through there and decide what to do based on different circumstances. And if you have a situation where some quote errors really aren't errors, like in a lot of cases the 404 is not it's technically a client error, but it's for a lot of web APIs it's a legitimate return value. It might mean this job isn't done yet. It's you poll in a URL until the job is done, and so allowing the client code to decide when an exception is raised instead of making that decision yourself can be a really kind thing to do to your client coders when you're developing your library. And you might want to come up with a middle ground, or you might want to come up with some options where you give them the ability to say yes, I want exceptions, or no, I don't want exceptions. We talked about this a little bit on Tuesday. A lot of libraries are wrapping up services or they're wrapping up C libraries, and when you do that, I think it often works out well to have kind of a tiered architecture where you start out at a low level with the thinnest possible Ruby wrapper. So it might be a very thin wrapper that wraps the C library exactly with the same names of methods, and that way people that are familiar with the C library can just go in there and they can immediately see the Ruby versions, and they can actually reuse the C library documentation, and these low-level ones are typically procedural. They're typically stateless, meaning that all of the state relevant to that call is going to be passed in the parameters. It's not going to depend on any other state, and they tend to have minimal magic associated with them. So there's going to be very few surprises. There's going to be very little magic conversion of values. For instance, the most that it might be is maybe it converts anything you give it into a string or something like that, but it's not going to do a lot of fancy conversion. And then on top of that, you build your object model, which kind of separates out the different concepts that are in that library, and builds a more of a convenience layer on top of that, and the state is represented in these objects. And if you do that for a while, what often actually emerges is more like a 3-layer model, where you have this thin as possible wrapper, and then you have 1 or more layers of glue as you factor stuff out, factor commonalities out of the object model layer, and then you have your object model layer. So those are some of the rules that I've come up with, but that's very, very far from complete. So I'm very open to finding out what are some other good guidelines that people have come up with. Who's written a library?
I'm patently terrible at it, but I've done it a number of times.
Well, then what do you think?
It's hard. I'm much better at writing applications than libraries. I tend to think there's 2 kind of mindsets that...
Sorry, hold on a second. We're still recording.
I tend to think there's 2 different mindsets of programmers. People who tend to think more at the application level, and people who tend to think more at the library level. And I don't think I fall as much into the library category. I think I've enjoyed a couple of successful libraries, decent exposure being one of them. But you can look at the code in the first version, and it's just like this horrible monkey patch of metaprogramming, basically. Thankfully, Josh Davey has been working hard to help clean it up for version 2 and actually make it an object model. But yeah, I don't know, man. Laying out libraries is very difficult for me to conceive of, but application level object systems make sense to me. So I don't know. Have you experienced that? Do you find that with other people?
The question is, have I found that there's sort of a different mindset for library development and application development? And yeah, I think so. I think some people are really, really good at structuring libraries, and some people are really, really good at structuring applications. But I think I think both mindsets are very amenable to being learned. Does anybody have any burning questions, like you tried to build a library and there was something that you couldn't decide or couldn't figure out?
How about more like, so at the start of your library, when you don't think about actually extracting everything and putting them all in different modules. Like when do you decide when to start, I guess, extracting things into named things?
When do I decide to start extracting things from application code? It's a good question. I have a habit of, like, if I'm building a Rails application, I will, if I decide that I need anything, any kind of facility which seems general, which seems like, basically any kind of facility that I build, I ask myself, is this specific to the application, or is this something that I could even imagine possibly in the far future, making it into a gem? And that's kind of my decision point for whether it goes in lib or whether it goes in, somewhere in the app hierarchy.
Right.
And
like lib's your staging area for
exactly
future gems, you were saying yesterday.
Yeah, right. So lib is kind of my staging area for future gems. They may never make it out of there. A lot of them never make it out of there. But anything where I'm like, yeah, this is kind of a general thing. It's not really specific to this application, or maybe it's specific to a family of applications, but it's not specific to this one. I'll just go ahead and start it out in lib rather than in the app hierarchy. And that usually helps with the extraction process, because particularly once it has more than a few files, I'll usually put it in, if it's the foo library, I'll put it in lib/foo, and it'll basically have the same structure at that point of, or beginning structure of a gem, where you would have in the gem, you'd have lib, foo, and then your library files. And so that, I think that helps me a little bit, because basically I'm building it as if it were an external gem. It's just the only thing that's left when I finally decide that it's time to extract it is the busy work of copying just those files out and putting a gem file in. I'm not, putting a
The gem spec?
Yeah, gem spec. Thank you. A gem spec in and registering a new repository for it, that kind of thing.
Yeah, I always seem to kind of stop short of that step. Like, I think probably the libraries that I don't have trouble building are the ones that are in fact extractions rather than an attempt to make an abstraction. But I seem to always stop short of actually making the library out of it. It's like, cool, I've got this generalized thing that I'm using in this application, but never put it up on GitHub. I'd open source contributor.
Well, you got decent exposure out there, and a lot of people are using that.
Sure.
True. Yes.
What about the your test coverage for the library? I've seen two types of test coverages. One is just just testing the library, and the other time is you use application to test it.
Right.
So what's your thoughts on that?
So what are my thoughts on test coverage for the library, especially when it's a library that's currently living in an application? Do I have separate tests for the library, or do I just test it as part of the application? I haven't come up with any hard and fast rules for that yet. A lot of times, just as a result of the way that development goes, the library does start out being tested by the application tests. Particularly at the integration level, it's being tested by the application test, because if the library doesn't work, the application doesn't work. I do a lot of unit testing, a lot of TDD isolated unit testing. So typically there are going to be, if I've built it, there are going to be pretty isolated specs around that library stuff that really don't talk about the application at all. But at the unit level, but at the integration level, all those tests might just be application tests. And that can be a little tricky, teasing some of that out. For something I was doing recently, I actually started, as soon as I identified a method that the application needed on the library that wasn't there already, I just completely switched over to writing a library integration test. And I wrote a generic library integration test that didn't really talk about that application, that would test drive the method that the application needed, and then once I had that working, I switched back over to application mode and drop that method into the code, or then maybe the test that I had gotten, the test point that I had gotten up to in that application would start working because now that method existed. And that was a case where I knew I was going to be extracting that library out, and so I really was kind of making a point of having a library specific integration test.
And at that point, you just say something like, in the application, you say, this library should receive this new method, and that's okay, because you trust that the library author has done due diligence and written.
Right. I mean, at the unit level, yeah. And a lot of times in my applications, I'll actually have a really thin layer that's wrapping the library, because I don't like to. It depends on the library. Really depends on the library, but I don't particularly like to tie my application too much to the details of a given library. So sometimes there will be a thin layer in the app that.
Like if it's for a web service, perhaps.
Yeah, like for a web service. There will be some thin layer that actually lives in the application, which abstracts the use of the library, and then that abstraction is what gets mocked and stubbed, and really it's just a translation layer. It's just a facade over the library.
Do you have any recommendations for libraries that are meant to be command line gems? How would you organize that, and also is there anything to consider with error handling because you're in the command line?
Right. Do I have any recommendations for command line for libraries which are intended to be command line or used from command line? So there's this great book about that, Building Awesome Command Line Applications with Ruby, I believe is the title. And disclaimer, I did some technical review on it, and so I have that connection to it. But I think it's a great book. Dave Copeland, that's right. And it has a whole lot of great tips for that. So I kind of leave that up to Dave now.
I'll read that one. Thank you.
So I think it's interesting you were talking about having the application level facade for dealing with third-party libraries, and this is kind of similar to the point that a lot of people are coming to with Rails development right now, trying to build up so-called scar tissue around points of interaction with it.
It's a good term. I hadn't heard that one before.
Yeah, so I think that whole concept of being more deliberate with how you interact with other libraries, even ones that we take for granted, like Rails itself. I think the arguments against it I've heard, are kind of the same as people who are just introduced to object orientation, like, oh, there's classes everywhere. How can I keep all of this in my head? And certainly there can, I think, come that point where the proliferation of classes becomes too immense, and then perhaps your design is bad in a different way. We've recently been trying to do just that, build up scar tissue around Rails and making diligent effort to test things in isolation, separating out persistence and business logic. So it's interesting to think of that as applied to third-party libraries in your own application.
That's a great term, scar tissue around libraries, because I think it can be fairly limiting. I've seen a lot of code bases where the code is sort of written to accommodate the library, and it's almost like written to mimic the README for that library. And even if that sort of conflicts with the style of the rest of the code, and that is what'll really lead to cognitive overload. I think more than proliferation of classes is having to be like, okay, I have to think in like this library mode now, where everything I do is an everything that could possibly go wrong is going to be an exception that I have to handle. And then you switch over to this other library mode where I have to do careful error checking of the statuses of each call, because that's how that library works. You don't want to be that kind of thing leads to bugs, because you can't keep all that in your head, and so you stop doing the diligence.
Yeah, I see many tweets about people having to work with a terrible library and whatever the flaws of its API is. And I think it was Ryan Big I saw not that long ago. Was confronted with an awful library. It did not like its API, so he wrote that layer between. So he ends up dealing with a nicer abstraction of it.
Yeah, and you never know. I mean, you write that nice layer over a crappy library, and maybe you can, maybe you can submit that to the maintainer, and they'll be like, yeah, I always wanted something like this, but I never had the time to do it. Right? So
it's another question, but it's more like without you being able to show some code samples. I was just kind of wondering if you could dive into what it would look like to build this facade in your application. I mean, or can you describe that conceptually or not?
Right. Can I describe briefly what it looks like to have a facade over a library? Well, I mean, it's going to be, for instance, if I'm interacting with GitHub, I don't care what the library that I use for interacting with GitHub looks like. I probably want something that is like a GitHub service class, which creates GitHub service instances. I'm big on instances. I don't like class methods. And it's probably going to have some methods on it that, just the methods on it, first of all, for the operations that I care about in my application. It may have some methods on it that are composites of calls to the underlying API. So it might be, maybe the underlying API doesn't have the high-level operation that I'm interested in. So maybe I have a method which sort of bundles up, the multiple calls necessary to do that high-level operation. Basically, I'm going to be. I want the operations in terms of that external API to be close to one-liners in my main code base, and to be a call on an object that I can control, so an object that I can inject into my other models if I want to mock it out, that kind of thing. Deeper than that, I guess, would really take diving into some code, but.
No, but that makes sense. Because that way, if anything at the low level, in the service changes, then the object that you're controlling in its implementation changes, and not necessarily how your application is interacting with that object.
And I might be doing some logging in there if I'm concerned about internal issues in the library that I don't necessarily want to bubble up to the application level, but I also want to be aware of. I might be doing some error translation in there if I want to translate one kind of exception to an exception that makes more sense in the context of my application. That's actually a good an important point. A lot of times the exception that you're getting out of the library may be very general, but in the context of the operation you're doing, you have more context about what you're doing with that library than the library does. And you may be able to supply some application-specific context about what was really going on, what exactly was going on. And so one thing that wrapper may do, it may rescue an exception coming out of that library and then wrap it in another exception, or tack on some information, somehow add some information to that which is very specific to what the application was doing from an application model point of view. And then when that gets reported, you can say, okay, we're having a problem with this specific application functionality, rather than we're getting all these GitHub errors.
Right.
When that, and I say, when you say that, that's going to be, when you see it reported in your
Box.
Yeah, in your inbox. Yeah.
So one of the things I think Active Record did right was the way they implemented the adapter pattern for the database adapters, and considered individually, they're of course implementing the adapter pattern so that Active Record can access all of these different backends in a uniform way. But each of those individually stands as a facade on its own. It wraps up an API for a gem that typically will access a C library, and then make direct contact with databases and stuff. But it does this in a homogeneous and uniform fashion.
More or less.
Fair enough.
I've written an Active Record backend, and yeah, it's actually not bad. And it was kind of a shame that nobody really realized that for a while. But yeah, so Active Record implements this idea of adapters for database backends, which then use the underlying gem, but they homogenize that underlying gem API into a single API that Active Record understands. And that was the very first gem I ever wrote was NullDB, which was a null object pattern for Active Record. And what differentiated it from some of the other stuff that was out there at the time was that I just looked at the API, the not particularly documented API, but it was there, that the backends were using, and I just wrote a new backend that just implemented that whole API and implemented all the operations as no-ops and effectively, and it worked, So yeah, that's having that adapter layer is great.
Can you think of any other kind of easily available or larger implementations of SOD pattern, particularly to kind of build up that scar tissue around usage?
Like in applications, or?
Well, not necessarily just in applications, but I mean, I think we see libraries that are built to consume other libraries that do similar things.
Well, one that I'm relatively familiar with is similar to Active Record. Data Mapper has to do the same thing. But Data Mapper has kind of an explicit goal of supporting every data store under the sun. So you can actually you can have an interesting tour of how people build up that scar tissue, that adapter layer around backends just by going through some of the Data Mapper adapters, because the Data Mapper adapter API has 4 methods: create, read, update, and delete. And the arguments to those are, I won't go into it here, but the arguments to those are actually really well thought out, and in such a way that it's actually possible to implement anything that you would want in terms of those. One interesting thing, I don't know how applicable this is to things outside the domain of database adapters or data store adapters, but an interesting thing that Data Mapper did was all of the queries have been implemented, all the query operations that it can do. It's got sort of a high-level definition, kind of like AREL now, but it was before AREL. It's got a high-level definition of what a query is, which is not bound to any kind of SQL or anything. And it has Ruby implementations of all of the query operations, so all the ands and all the unions and the intersections and predicates and things like that. That's all implemented in Ruby. And the interesting thing about that is that you can write a quick and dirty, like incredibly quick and dirty database backend, which just sucks in the whole database, and then you can run the full gamut of queries over the data that you get back. It's just that they're all going to be interpreted in Ruby. But then what you can do is you can incrementally take out parts. You can incrementally go through and say, okay, this is really slow. I'm going to implement unions now, and like basically take that out of the Ruby land and put the unions in the in the native land. But maybe you're not supporting intersections yet, so the intersections fall back to the Ruby handling. And so the cool thing about that, because they built that whole layer, on the client side, when you're just using the back end, you don't have to be like, which of these is implemented now for this back end and which isn't. You can just use them all, and then the back end implementer can gradually replace the slow Ruby versions with the fast native versions as they come, figure out like which is the most important one to do next. Not sure how far you could apply that to other types of systems, but it may be applicable.
See you all next time.
Next time.
Till next time.
See you, I will.
See you then. You can grab any or all of them if you want.